This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI Podcast. My name is Peter Seeberg, and my guest today is Will van der Aalst. Will is full professor at RWTH Aachen University, leading the Process and Data Science group. He's also chief scientist at Shownotes and part-time affiliated with the Fraunhofer FIT, member of the board of governors of Tilburg University. I may come back to that later for insiders. He's an IFIP, IEEE and ACM fellow and received honorary degrees from a number of universities. He's elected member of several academies, and in 2018, he was awarded an Alexander von Humboldt professorship. So today, Will be talking to us as professor at the RWTH Aachen. And in addition to all the activities I just mentioned, and there's probably even a couple more, Will is known as the godfather of process mining. So no coincidence that we are going to be talking about object-centric process mining. Hello, Will.
Yeah, it's a great joy to be here.
Please introduce yourself to our listeners. Let us know what you do at RWTH Aachen University, plus maybe one or the other role I just mentioned to share with our Industrial AI podcast listeners.
Yes, I think you gave an excellent summary of the various things that I'm working on. So at RWTH Aachen University, I'm leading process and data science group. So in our group, we try to combine both, let's say, data science, and you can interpret this very broad, like machine learning, AI, etc. And we combine that with what we call process science. You could also think of that as business process management. So we have, let's say, several courses in the field. I'm leading a group of around 30 people. Because this is the Industrial AI podcast, I'm also, let's say, co-leading like a big excellence initiative. These are these very prestigious projects in Germany. That's called Internet of Production, which I think is exactly on the topic that this podcast would like to focus on.
Sounds great. And the reference I just made before, Tilburg, I studied in Tilburg as well, not the university, but what today they call the applied sciences, I believe, right? So
yeah.
I recall that you have a Prof. DRIR for, it's the Dutch version of the university engineering title, I believe, right?
Yeah, I still see myself as an engineer. Yeah.
Very good. So before we go into object-centric process mining, first let us have a quick introduction into process mining. What is process mining? Why do we apply it? Since when has it been around? And where is it typically being applied?
So process mining is based on extracting event data from information systems. So this could be SAP, Oracle, or any system that people have. We extract these event data, and based on these event data, we automatically construct process models which are showing what is really happening. So by that, you see the real inefficiencies, you see the real compliance problems. And I think for people that are new to the topic and see process mining results for the first time, it's often incredibly surprising because people have a kind of idealized view of their own processes, and then they do process mining, and then they are often shocked by like how different these processes are and how many deviations are there. So process mining starts by making people aware of the fact that reality is very different what they think, and that is often already incredibly valuable. And then after people are over the first shock, realizing what their real processes are, one moves to topics like what we call conformance checking, where you kind of create a model of what you think should happen or what you want to happen. And then you can, let's say, pinpoint the biggest deviations. We often talk about execution gaps. So we then see what are the biggest deviations between what we want to happen and what actually happens. And based on that, you can automatically trigger actions that try to address these problems that you see. If companies have enough data and processes are relatively stable, one can also go more into predictions. So, for example, predicting that a case that you're handling now will be delayed, or a case that you're handling now will be deviating, or a bottleneck that is not there today that most likely will be there tomorrow. So you see all of these, let's say, problems very explicit. So unlike traditional modeling and simulation approaches, it is not subjective, it is really objective. It is really based on the data that is there, and therefore it's incredibly valuable. So what many people do not know is that, for example, already at this stage, half of the Fortune 500 companies are already using process mining. So it's not something exotic. It is something that is very real and being applied already by the larger companies. So you also asked me since when, right?
Yeah, right. Is it a new thing, or since when does it exist?
So I have a history working on, let's say, workflow automation. So in the mid-90s, I was specializing in both building and evaluating, let's say, workflow management systems. And I saw that they were not working in reality. And the reason was exactly as I explained before, that people typically have a very naive understanding of the real processes, that they oversimplify it. And therefore, I saw all these automation projects failing. And that is why, like at the end of the 90s, I started to focus on process mining, because I saw the huge gap between, let's say, PowerPoint presentations and reality. And I felt that a data-driven approach was the way to go. And then, like for a very long time, I was, let's say, more or less the only one, or my group in Eindhoven back then was the only group in the world systematically working on this topic. And only later, let's say, several of my students, let's say, started process mining companies. At this stage, there are around, let's say, 40 commercial vendors of process mining software. So there is really something that you can pick from. And now it is becoming increasingly normal, at least, let's say, in this part of the world. As an indicator of that, I think there is the success of Celonis, where I'm the chief scientist. So Celonis is seen in Germany as the most successful startup, let's say, valued over, let's say, $13 billion. So this is quite substantial. I think you also asked, where is it applied? And this is super broad, right? So process mining is applied in all industries. So all car manufacturers are using it, telecom operators, insurance companies, banks, you name it. Like, it's a generic technology that can be applied in any organization of some size.
Very good. First thing I learned from you is it's an eye opener. And I recall that was more when I was involved myself, colleagues doing data science. And that was more from a statistical approach, I believe. So in the first meeting after we got the job to do, and we looked at the data and provided it back through statistical graphical means, it was very similar to what you just said, always very eye-opening. And then there was a very good mood that we could move on with the real thing. And the other thing that I thought very interesting, what you said is comparing to at Intel, where I was many, many years, but I was more in the marketing space. That was the quote, perception is reality. You know, what people believe as far as brands are concerned, let's say, put it like that, that is the reality. And in your world, in the world of process mining, you say it's completely the other way around. You say people have a certain belief of how their systems, processes work. And you showed him that that is maybe not always, or most of the times, not the case. So you mentioned very general where it's being used. Maybe you want to pick out one or two typical use cases, maybe a general one, maybe one in industry, a little bit more in detail. What is the environment of such a use case?
Happy to come back to the remark that you made before. We often talk about the 80-20 rule when we talk about processes. So I think the reason that people have an oversimplified view is that, let's say, 80% of the cases that one is handling can be described with a relatively simple model, right? And then people start to believe this is our process because it covers 80% of the cases. But if you look at the remaining 20%, if you look at all the inefficiencies, all the waste, all the problems, they are exactly in the 20% that you tend to leave out when you talk about, let's say, the highways in your process. And I think that's what makes process mining very valuable over, let's say, BI tools that tend to focus on, let's say, the mainstream. Your problems are in the 20%. Then to come back to your question, I'll give two examples, right? So one example would be a process like purchase to pay. So most of the larger organizations have this process. So this is the process if a company wants to order products from some other company. This is a process as of people that use SAP, like the data that relates to this process is completely clear. So you can easily extract the event data, and then what you see is that these purchase to pay processes are typically much more, one think it's very, very simple, but there are, let's say, there are many variations of this. So a typical problem that one encounters is, for example, that often a supplier is changing prices, and you find that out while you're executing the process. And if you are aware of the fact that certain suppliers are often changing prices, you will take actions like updating the prices earlier or not working with these suppliers anymore because it's creating inefficiencies. Another thing would be like maverick buying, so that people in the organization are trying to bypass part of the purchasing process. And that is both generating, let's say, extra work because you have to correct these types of behavior afterwards. And for large organizations, this is very costly. And you also typically are buying products for higher prices because if you don't purchase in an organized way, you're missing out on economies of scale and these types of things. So these are typical processes that any organization has where there are known inefficiencies. And if you use process mining, also quite some work has been done already to quickly identify these inefficiencies, and then you can address them automatically. So this is one example, and I could give many more, of processes that any organization has. Another example, just to sketch the spectrum a bit, a few months ago, I was speaking at the Lufthansa conference. It was an internal conference in the Lufthansa, where one of the topics was the usage of, let's say, process mining within Lufthansa. And Lufthansa is, on the one hand, using process mining for the standard processes, as I just indicated, but they're also applying it to processes that I find very interesting. For example, how to minimize the delays at airports. So the main hubs of Lufthansa are, let's say, Munich Airport and Frankfurt Airport. And what many people do not realize is that if a plane is landing, comes at the gate, that there are many events being recorded, such as, gate open, gate close, but also fueling starts, fueling is completed, baggage loading, baggage unloading, cleaning crew going into the plane, coming out of the plane, etc., etc. So there are
boarding completed is one of them,
yeah,
where sometimes you need to be in the plane, and then they tell you that we still need to wait for an hour, but we had to be in the plane. If not, we would not be on the list, right? Yeah, I recall.
So there are around 80, let's say, unique events that are being recorded. And Lufthansa is using, let's say, Celonis process mining to try to minimize these delays. And you have to realize, as you just indicated, this is a process that is highly concurrent. In principle, many things can happen at the same time. People can get into the plane while you're loading the baggage. So it's a very concurrent process. But if one of the things goes wrong, the whole plane gets delayed. And if you think about European flights, you often just have 1 hour between the plane landing and taking off again, which is very much time constrained. And the same plane can make, let's say, 8 flights per day. And you should imagine that if something goes wrong in the morning, you have this cascade of problems throughout the day. And that shows that process mining can really help you to find the root causes of, let's say, delays in real time, right? So you're constantly monitoring, what is the performance when we look at the cleaning crew, etc., and what is causing the delays. And this is a process very different from purchase to pay. But I think everybody can imagine, okay, this is something that is time critical, where process mining can have incredible value. And also Lufthansa is claiming that they have been able to address many delays that are not there just because of process mining.
Very good. And I can imagine for myself, can very well understand your example of the delays at the airport to be representative for any logistics in, a factory environment. For example, interesting how you started talking about the Pareto rule, concentrating on the 20%, if I understand correctly, of processes that are in charge of 80% of the problems. So what then are typical process mining tasks? Maybe, again, along the lines of one of the typical use cases.
Yes, if you look at the main stages of process mining, and these things are very generic. So first is extracting data. And for example, if we take the purchase to pay example, you need to extract data from, for example, SAP. And if it's a well-known process like purchase to pay, this is relatively simple. If your process is more, let's say, one of a kind, it is more difficult. I think many people know that SAP has around 800,000 different tables. Saying I mine now SAP data is a sentence that does not make any sense, right? You need to really focus where you can get the data from. And for known use cases like purchase to pay, order to cash, it is known which tables to look at. So the first step is extraction. Then the second step is what we call process discovery. So you automatically discover what a real process is. And this is, you can just imagine it as pushing a button. And while doing that, you may want to focus on the highways in your process. You typically have a slider where you can say, okay, I now want to see the high frequent paths through my process model. But you can also decide to basically look at all the paths, and then you typically get a spaghetti-like diagram. So that is the discovery step. So in the purchase to pay example, you would see all the activities like creating a procurement order, getting approval, the fact that things are actually delivered, etc., etc. Then what typically happens if you have this data collection under control and you're over the first surprise effects is that you do conformance checking. And that means that you turn the discovered model into a normative model, which describes what should happen. And then you take this non-normative model and you constantly compare it, let's say, with reality. And if you see, for example, bottlenecks, if you see, let's say, deviations, for example, that certain approval steps are skipped, like in maverick buying, these things are indicated. So that is what we call conformance checking. The third step, and I think most organizations are not mature enough to do that yet, but process mining tools also provide the capabilities to predict. So these are forward-looking techniques where, based on the historic data and the current state of the process, you can predict, for example, whether a case is going to be delayed or not. As I said, I think most organizations are not in the stage where they can meaningfully apply these, let's say, predictive techniques. I think much more is to be gained from the, let's say, discovery and conformance checking phase. Then the phase that follows after that, so think of the predictive stage as something that's optional, that most organizations cannot reach. Then the final step is, of course, to take action based on the things that you have seen. So if you take conformance checking and you, for example, see a supplier that is frequently changing prices, or you see a certain bottleneck that regularly appears in a specific part of the process, you can automatically trigger workflows which address these types of problems. Because it is quite pointless to just, let's say, diagnose process. You also really need to change processes, because that's the only way that it makes sense. And process mining software, like, for example, the Celonis software, allows you to trigger these actions. So, for example, trigger workflows that, let's say, if you see certain problems, that you address these. because that's the only way that you get this success story.
Very good. So, and specifically understand the predict task or phase is where machine learning takes place. As usual, predicting is typically what machine learning does. We'll get back to that later. So now we have received kind of a very base introduction into general process mining. Maybe a very quick 2-3 sentences introduction into the object-centric process mining. Can you do that?
Yeah. So object-centric process mining is like a super important innovation in our field. And it's a bit technical, but people tend to look at the process model. If you look at the process model, you're looking at the handling of one, what we call a case. So, for example, you're handling a patient, or you're handling, let's say, a production order. So you typically focus on the activities related to handling a single object. And object-centric process mining generalize this to the level where any event can refer to any number of objects. And this has incredible advantages because it allows you to much better look at the processes as they really are from any angle. As I said, it's a bit technical, but it's a super important innovation that makes it easier for people to apply process mining and also makes process mining much more flexible, avoiding certain distortions that you normally see if you look at process models with data projected on them.
Very good. So before we then get into the object-centric process mining, maybe 2-3 more details that are probably helpful for then understanding regarding the more general, I believe, process mining. So if we talk about the business process model and notation, I think it's called BPMN standard. You want to talk about that?
Yeah, so the BPMN standard is these days the de facto standard how organizations model their processes. So this is like a diagramming notation where you model activities, but you also model the ordering of activities. And it allows you to model sequences that certain steps are happening in a fixed sequence. It allows you to model choices. So for example, after this activity, we either do this activity or this other activity. It allows you to model loops, but it also allows you to model concurrency. And concurrency is super important. Earlier we spoke about, let's say, minimizing delays at airports. If you see what happens to a plane between landing and taking off again, this is not a sequential process, right? There are many things happening at the same time. And the BPMN notation allows you to model these concurrent processes.
Very good. So what is the type of data then that is being used? And is there then a specific difference? You said, you need to know where to look for your data. You need to know what kind of data it is that you need, that you have been needing, and maybe you're going to need different kind of. Is the object-centric event data, is it different from the traditional event data?
Yeah, so if you look at the classical event data, then you also see that the notion is very, let's say, general. Classical event data describes events, and events can have any number of attributes, for example, temperature or location or these types of things. But there are 3, let's say, attributes that are mandatory for any event in the classical setting. That is, you need to have an activity name. This could be payment, or a sent invoice or something like that. This would be a timestamp. When did it exactly happen? And it refers to a case. So a case could be a production order. It could correspond to a shipment, to an invoice or something like that. So these are the 3 mandatory attributes: activity, timestamp, and case. If you look at object-centric event data, you typically relax the last constraint. So an event no longer needs to refer to a single case. It can refer to any number of objects. So that means that if you think of an assembly step, you don't just refer to the object that you're producing. You can also refer to the parts that are taken together in an assembly step, but also, for example, the machine that is being used, the operator that is involved, the location. Any number of objects can be involved. And this makes it very powerful.
It sounds to me that, like, in a typical manufacturing industrial AI environment, the time series that we have been gathering for many, many, many years. And many, many years ago, we always didn't know what to do with it. Maybe we only used it passively when there was a certain charge at the consumer side had a problem. We would go back and see what had happened. And of course, today we're using it very proactively. It sounds like when you say the second attribute, the timestamp, that's a typical what we call time series in our environment has always been provided by the typical MES systems. So that gives us a long way as a good basis for process mining, for also the process mining.
Not really. If you look at like typical time series data, like one needs to look closely what it actually represents. When you do process mining, you're interested in discrete events, right? So if you have, for example, a machine that is doing some operation, and every 10 milliseconds, it stores, the forces and the location, etc. That is time series data, but these are not necessarily events, right? We often distinguish a bit between measurements and events. So an event, a measurement is something that you do. An event is something that has happened. So these two are obviously very closely related. But what you see is that if you look at time series data, you typically want to process time series data to turn it into discrete events again. Think, for example, that's a case study that we had. Think of wind turbines that are standing in the field. And the wind turbine is measuring every so many seconds. It is measuring things like wind speed, how much power it is delivering, from which direction the wind comes, etc., etc. So it's recording these things, for example, every 5 seconds. And then if you want to turn that into a process mining problem, you typically want to look at such what we call continuous data, and from that distill certain events. So, for example, the wind turbine is switching off. The wind turbine is generating an error. The wind turbine is now moving to, let's say, a special setting that only applies in storm situations. So you typically, why I'm stressing this is that in some applications, you need to first translate, let's say, continuous data into discrete data. And it depends a bit, like, let's say, how natural it is. For the processes that I spoke earlier, if you think about the airport and the purchase to pay, these events are discrete in nature. So baggage loading starts, baggage loading is completed, right? These are very discrete events. This is not something that you would easily describe as a time series.
I'm with you. I've actually been involved myself in PCB production where there are 10, 15 different stages. And at that time, my colleague data scientists already were telling us the MES data that we had, and you could probably say they were the typical time series data on time, pressure, etc., etc. And in the end, we could do something, but my colleagues said we would need the data from the separate machines. So it feels a bit like is what you are telling me and our listeners here that we need to translate the time series, the temperature, pressure, and all the things that we measure every millisecond, as you say, into events like data inspection, plotting films, scrubbing, printing, whatever all these 15 or 20 different stages do until at the end there's a copper buildup.
Yeah, sure. And for example, I mentioned this cluster of excellence, Internet of Production. That is one of the exciting things that we are doing, that we are trying to combine, let's say, this more discrete event data with this more continuous time series data that we then try to convert one into the other in order to try to combine the best of both worlds.
I understand that one of the reasons or the way that you put it, why are you moving towards the object-centric, is you've been talking about a convergence and divergence problem, which typically occur in traditional process mining and maybe have been the reason for. Can you give us 1-2 examples of those?
As I said, this is a bit technical, but at the same time, anybody in industry who has done process mining at a larger scale immediately understands it. So the point is that in the classical setting, every event needs to refer to a case. So for example, if we take the example of a production order, then every event needs to refer to a production order. But in many situations, it is not so clear, and you need to attribute it to, let's say, more objects. Just as an example, imagine the scenario where there is one customer order, and that customer order consists of 4 items. Of these 4 items, 1 item is in stock and 3 still need to be produced. That means that of this one customer order that has 4 items in it, you need to create 3 production orders, one for every item that was not in stock. The item that was in stock is being shipped immediately. The items that were not in stock, they are shipped later. So you have 2 shipments, and at the end there is 1 invoice. So what I just described you is a very basic scenario where we had 1 customer order, we had 4 items, we had 3 production orders, we had 2 shipments, and we had 1 invoice. And I could also add customer and supplier and all kinds of other stuff to it. But it shows you that in this process, many things are involved, let's say, at the same time. If you apply classical process mining, you need, in this setting that I just said, you need to decide, okay, what is now my case notion? Is it the customer order? Is it the item? Is it the production order, etc., etc.? And if I, for example, would pick item as a case notion, that would mean that, for example, the placement of the order would take place 4 times, because I'm using that as my case notion. So if I draw a process model, I just want to talk about items, but you get the distortion because if the order is being placed, that was one event that you had to replicate for all of the different items. So if you do it in a classical way, these are the typical things that you see. And the reason is that you're, let's say, modifying reality to fit into this mandatory template where every event needs to refer to one case. And if you don't do that, you're recording things in the way that they really happen. And that provides you models that are much richer, much more expressive. And at the same time, you don't have these distortions that you often see if you apply classical process mining.
Very good. Let's talk about process mining algorithms. Am I correct in assuming that maybe, for the classic process mining, there have been what I call more like rules-based, and where, if at all, does, and I understand it's specific, we just talked about it in the predict task, does machine learning come in?
So if you look at process mining algorithms, the core algorithms are very unique. They are very different from what one sees in other fields. So, for example, if you think about something like process discovery, you get event data and you automatically want to create process models. Most of the standard, let's say, data mining and machine learning techniques, etc., do not consider processes at all, right? So you think of, let's say, classical data mining task would be something learning a decision tree or something like that, or things like regression. These things, you can also think of them as discovery, but it has nothing to do with process discovery. So there are many unique algorithms there. If you think about something like conformance checking and you look at the underlying algorithms, again, it's very different. I would say it is much closer to optimization, solving, for example, linear programming problems and these types of things, than it is to the things that people expect, like, for example, in the context of machine learning. So these core algorithms are very different. Of course, one could call all of these things machine learning, but I think in the field, we currently have a bit of a confusion about terms. So if you define machine learning as using data to automatically learn things without actually programming them, you could say that something like process discovery is a form of machine learning. But the way that most of the people, when they talk about machine learning, what they actually mean, they're typically referring to deep learning and neural networks and these types of things. And neural networks and, let's say, deep learning and all of these things are very different from process discovery and conformance checking and all of the core techniques. Where machine learning plays a role is that after you have done the discovery and after you have done the conformance checking, you can use process mining to generate standard machine learning problems that you can then apply. So if I can name an example, suppose that you have a production process, and in that production process you see a certain bottleneck that is not always there, right? It's sometimes there. On some days it's there, on other days it's not. Then you first do discovery, then you do conformance checking, and then you use process mining to generate a machine learning model that helps you to predict when that bottleneck is there and when not, right? So you can think of process mining as an enabler for applying classical machine learning algorithms. But in order to do that, you need to use algorithms that are very different from the mainstream machine learning problems. Of course, in these days, we also need to for example, talk about things like large language models, like GPT. Also, that plays a relatively minor role in the field of process mining. So where that is, for example, used is that we use things like GPT and other large language models. We use that to allow people to interact with process mining software using natural language. Like if you look at the core, it is using process mining algorithms, but these, let's say, these kind of fuzzy new techniques are being used to translate natural language. For example, the question, what is the main cause that in this part of the production process I have the biggest problems? That is automatically being translated in, for example, PQL, the process mining query language, in such a way that people can more easily interact with it. But it doesn't relate to the underlying techniques that are there.
Right. It's more the user interface for the humans, right?
Yeah. Yeah.
So as you use the word cause here, a couple of months ago, we had Michael Haft. He's the founder, CEO of Explain Data. You may meet him in Berlin, more to that later. And he talked about correlation and causality. How do object-centric process mining and causality relate, if at all?
Like if you think about most machine learning approaches, they are like black box. So based on data, you try to learn something, and then there is this magical neural network that then makes certain decisions. It is important to realize that process mining is not black box. And so when, for example, Corona happened, or when we started to have the supply chain crisis, all of these black box techniques did not work anymore because you were confronted with the situation that was very different from, let's say, the data that you learn things on. But process mining still worked. It still worked because it is creating models that people can look at. And we often use the term hybrid intelligence, where on the one hand, you're showing process mining results. On the other hand, people still need to make certain decisions to add extra resources there. So one of the things why I'm saying this is that if you look at causality, this is often the problem. If you have a black box technique, like you may infer completely the wrong conclusion. So for example, you could say, okay, if people start using umbrellas, it will start to rain, right? Where there is a correlation, but the cause effect things is in a different way. In process mining, you have less of a problem because these models are not black box. Of course, we are doing, let's say, research in this space. One of the things that we also realize is that, like, if you look at predictive models, right, we had situations where we could precisely predict what was going to happen. But at the same time, if we would make an intervention, the effect would be completely different. And I think also people that, let's say, talk about these causal models, they often do not, like this is more like an ivory tower type of discussion. it is very important to realize that even if you are able to predict things well, it doesn't mean that you are able to create interventions, because after you apply an intervention, the data that you learned on is no longer valid. So we had examples where we, for example, could predict certain problems, and then we would take action on them and we would make it worse, right? Despite all the knowledge about causality, etc., etc.
Very interesting. I understand that you have a more implicit causal relationship, if I may put it that, or closer towards the causal relationship, so to say.
The goal of process mining is to make interventions that actually improve the process. But the moment that you make an intervention, your process is different from before. And therefore, it is very important to do this, let's say, continuously, that you can also learn, okay, if I now make this intervention, then that has a positive effect. If I make that intervention, it does not have a positive effect. And it's something that you need to learn by explicitly doing. If you only look at the model, it is very risky.
One more question before we come to a close. There's a couple of ones that I need to skip. We don't have the time. Very interesting, all of this. Who is then the person applying? Are you, your colleagues, the people applying process mining, are they data scientists? Are they process miners? Are they typically a very different kind of person with different kind of knowledge?
Yeah, so if you look at larger organizations, think of Siemens, BMW, etc., etc. All of these larger organizations have special teams. So sometimes 10, 20 people for a large organization that are specializing in these types of things. So the ideal kind of people are, let's say, is a mixture between people that are on the one hand are a data scientist, but at the same time are also interested in the process. I think combining these two skills is something that is very important. So at the core, in a large organization, there will be, let's call them experts, that are able to combine data science with process science or domain knowledge. At the same time, it is very important to stress that these are not the only people that are consuming this. So, for example, I mentioned earlier companies like Siemens and BMW. In these organizations, there are thousands of people regularly looking at process mining results, right? So the person that is maintaining this data pipeline is a different person than the person actually making decisions in all of these processes. And therefore, I would say there are these two roles. There is a smaller group of experts, and there is a larger group of people that have absolutely no skills in, let's say, data science whatsoever, but that can look at these process mining results on a daily basis to see how they should intervene. Because, as I said, in the end, the goal is to improve processes. And you cannot improve processes if you stay within the small group of process mining experts. You need to, let's say, show this to a large community of people that are using this every day.
As a service to many, many more other colleagues. Coming to a close, I think we've understood that the object, especially the object-centric process mining, is relatively new. So if I'm going to ask you what the status is in different parts of the world, Germany, Europe, maybe USA, China, and how process mining, or specifically then object-centric process mining, is going to change the world specifically of, in this podcast, industrial AI over the next couple of years. What would you say?
So like process mining itself, one could argue that it is a relatively, let's say, young technology, where it is very clear that process mining is well adopted in, let's say, Europe. So not just Germany, but also countries like the Netherlands, Italy, Spain, etc., etc. So process mining is increasingly becoming normal in Europe. It is also starting to take off in countries like the US, Japan, India, etc. But there it's clear that adoption is lagging behind when you compare that to Europe. At the same time, there are exceptions, like, for example, when you look at a country like Australia, I think there is a lot of maturity when it comes to process mining. Yeah, so it's very diverse, but I think, let's say, large parts of the world do not know that it exists. And if they would know that it exists, they would immediately apply it. Because like any organization has increasing amounts of data, and there is no organization that doesn't have process problems, right? So it's completely logical that this technology becomes, let's say, mainstream. This is kind of also reflected by the fact that, for example, Gartner this year, for the first time, they released a Magic Quadrant completely devoted to process mining, which is kind of showing that it is becoming like a separate category. If you then go to the object-centric part, this is, let's say, even newer. So in research, it is becoming, let's say, a very important stream, with many papers on the topic, also dedicated workshops. So there it's very innovative. If you look at the industry, then Celonis is one of the very few that is now supporting this. But my expectation is that, let's say, all of the other main vendors will go into this direction, because it is completely logical as the area is maturing. Yeah, so I think this is we're still at the start of this development, but I think it's completely clear that in the next, let's say, 5 to 10 years, object-centric process mining is going to become the new normal way of doing things. If you look at the industrial AI world, I think what you see is that most organizations start with processes like purchase to pay, order to cash, and these standard things. And the reason is that there is a lot of experience with analyzing these systems, and this experience means that it is very easy to extract the data necessary to do this, because we know what kind of data is there, how to extract it. And we also have learned a lot about, let's say, typical problems that we see in these types of processes, where process mining immediately produces value. And so this is a very easy sell, right? You go to an organization, they have these processes, and you can immediately create value. If you go to industrial processes, when you look at the technology, process mining can also immediately be applied, but there is less experience, and most of the processes are more one of a kind, right? These are the core processes of an organization, where there are not, so purchase to pay and order to cash are processes in any organization. If you think about, I don't know, a very specific assembly process of cars or something like that, or a very specific chemical process, it is clear that there are fewer organizations having exactly that problem. So there, the applications are, let's say, fewer in numbers, but the possible gains are, of course, much higher, right? But it requires, let's say, a higher maturity of the organization in order to be able to apply these types of techniques. So I think that in industry, this will be increasingly applied, but I think most of the organizations will start with the standard processes and then move into the processes which are more unique for the organization itself.
Very interesting to hear also your view on how the process mining, specifically object-centric, maybe will be introduced also into industrial environments. And more interesting even how there is this great new technology where it seems, according to you as the expert, Europe is leading. That doesn't happen very often. Well, thank you very much. Those listeners that may want to get in touch with you can best do so on LinkedIn, Will van der Aalst. And if you, dear listener, want to see and hear Will present in person, feel free to join us at the Machine Learning Week Europe in Berlin. That's going to take place November 15 and 16, where Will be giving a keynote. Mind Your Own Business. It's called How Object-Centric Process Mining Improves the Things You Do Not See, which we now already understand roughly in what direction that we'll be going. We'll put a link in the show notes. Looking forward to see you there. Otherwise, if you, dear listeners, have any question, comment, as always, please send a short email to peter@ipod.de. Happy that you have stayed so far with us. Looking forward to have you with us again next time. And Will, thank you very much. Looking forward to see you in Berlin.
Thanks a lot, Peter. It was a pleasure to talk to you. Indeed, I hope to see you and many other people in Berlin.
Thank you. Bye-bye.
Bye-bye.